This week on Mavens of Data, we're speaking with Terry Dorsey about the difference between data fabrics, vector databases, and knowledge graphs, and the pros and cons. We'll chat about why structured data and schemas are still crucial in the age of LLMs and embeddings, and how knowledge graphs help model context, relationships, and episodic memory more completely than other approaches. Hope you enjoy this episode. Terry, so excited to have you today. I'm so excited to dig into this, to sort of set this episode up. When we hear new terms, sometimes it can be a little scary. And so I know I've used vector databases for RAG use cases. I've used knowledge graphs to actually look at the graph and see the relationships and share that with stakeholders, but I've never used that for, working with LLMs. And then there's also this whole concept of data fabric, which honestly sort of eludes me. So if you could just sort of give us the conceptual understanding of these three different terms, I think that'd be an awesome place to start.
Okay, yeah. All right. So in the vector database space, or vectors in general, this is a way of translating things like text and images into numeric representations that algorithms can understand. The key thing, I think, around those, particularly when we talk about this, a lot of the RAG stuff that we hear today, is the vectorization approach. How you actually embed and create those vectors matters. Traditionally, what we do in the unstructured area is we embed information using models that kind of try to figure out where it lands in the semantic space, or where it means, where the meaning is. So if I encode a document or sentences or phrases, I create these numeric representations that give me an idea of what it means. And if I have a document that is close in the vector space to another vector space, the idea is that there is this closeness or around meaning, that they mean something similar to each other. And so you can imagine that when you do all this embedding, you have many things in this high dimensional space. And that's kind of the idea around vectorization as we typically use it with RAG. And the approaches matter. So for instance, with text, there's embedding models that'll do meaning, but fundamentally you can embed graphs and other things as well. It's this idea of what is your approach to how you create those vectors. And so that's the vector side of it. When it comes to graph databases, I think, as you alluded to earlier, it is a matter of representing information based off how the actual information is related. So if I take subjects and actions and objects out of text, I can map them in a graph space, and just say how that information is related. And additionally, I can also embed it based on those relationships. So when we think about the embedding, we're going to get different outcomes. If I embed it based off of meaning, I'm going to find things that are semantically similar. If I embed things based on how they're related, I'm going to find things that are closely related in space. But how I look at it is going to be based off of the process that I actually use in order to create those embeddings. Graph databases have other really good uses as well, right? So there is this idea of being able to create things and relate them together without having to have hard schemas like we're used to in relational structures. Many graph vendors will incorporate data science algorithms within their graph implementations as well, so that you can actually do analysis on graphs as well. One other area that I want to talk about that kind of closes the gap. So we have meaning, we have relationship, and then we have this idea of structured data that we all understand today that sits in either RDBMSs or other structured forms. And this idea that we can leverage SQL or analytic approaches to those. This, if we look at all three of them together, they kind of close all of the ways that people actually go after information, right? We find things, we think about things that are similar, we think about things that are related, And we think about things that are analytic in nature. And you can imagine if you put all those together, how robust AI applications can be based on that. Where the data fabric comes in, the data fabric is this way of saying all of the information that I have within my organization or enterprise, I as a consumer, either an AI developer or a business user, I really don't want to worry about all of this technical complexity of where things are. So if there, where is this, wouldn't it be really cool if there's this way that I could get access to my organization through things that I understand, like business entities, like a sales order or a customer, or a product. And data fabrics allow us to do that so that we as people that don't understand all of the infrastructure behind it can be very, very productive. They also allow us to simplify how those things are secured and deployed and give us the ability to reuse them. So on the consumption side, it really simplifies how we can work, how we can innovate, and how we can be almost autonomous in how we use information. On the technical side, it means that I can make decisions based off of costs, speed, and other things as to how I actually hook that information up for my business consumers to use. And I think that's probably the simplest explanation that I can give for that.
Awesome. Thank you. So, right. So a vector database is a database and we're storing vectors. And a graph database is also a database, and it allows us to get at complex relationships like, a fraud ring or whatever that would be difficult to understand with a relational database. But now the data fabric, that's not a database, right? Like what it's like somebody, like who says, I need a data fabric, and what got them to that place where they say we need to set up a data fabric?
Okay, so for example, in my previous employer, we were embarking on a very, very large strategic artificial intelligence project. And as part of that project, the goal in that was to have our product developers and business users be able to interact with the information. But more importantly, we were working with artificial intelligence experts and data scientists so that they could then build models. Right now, you can imagine as a data scientist, right, there are certain how that process works. It's an iterative process. You have to be very agile. And from the business side of it, if you want to create some type of algorithms or AI around product development, you can imagine the breadth of information that you would have to have access to, and in a way such that you can iterate and become very agile. And so what the architecture was for that was, let's make sure that any interaction that we have with our data scientists, with our business user, is based off of logical representations of the enterprise, because that way they could be very productive and everybody could be very productive. And that architecture was enabled us to be able to say, hey, look, these are some formulas, these are some bill of materials, these are some shipments, you go and build your models off of these entities and features. So basically it's almost like they're feature stores, right? So I can give you feature stores and they will remain consistent. And if I add features, you have access to those features, and you don't have to worry about where that information is coming from, how it's validated or anything. That is handled by the technical side where it hooks information in. And so what that means is I can pull information from anywhere in my organization. I can pull it from graphs. I can pull it from RDBMSs. I can pull it from APIs. And all of that stuff is encapsulated so that all my business or my consumers had to do was work with objects that were within the enterprise. Yeah. And as a result, it really facilitated the agility, right? We're like, okay, this feature is not working. Maybe we'll try something else. So we'll figure out a source of it. Here's the feature, right? So you can build your piping or your plumbing and you can start working on your models, and the information will just be connected for you. And so from a speed and simplicity perspective, it works very well. Additionally, once these things are created, they can be reused for other things. And they can be secured. So we were working with third-party researchers, and we had to mask certain data as well. And we had to mask it so that it still worked within their algorithms. So we could use that same model and have different consumers. And as a result, we were able to complete that within 1 year.
Awesome. Awesome. Okay. And so the last couple years, it's felt like vector databases have really had their heyday. We started, talking about them a bunch. It seems like most businesses are using vector databases with their RAG models that they're building. What are they good at? And then what are they not so good at?
Right. And so, yeah, RAG, everybody started off gung-ho, but then a lot of companies or implementers quickly realized that semantic search is really not sufficient, right? Mm-hmm. So when people start asking questions, you just like you think of your experiences with ChatGPT, when you go into it, you ask it one question, oh, wow, it answers this. Let me just go get buck wild with the questions that I'm going to ask, right? So I'm going to ask it all kinds of questions, right? And so people had this idea that if I vectorize all of my static information, then that is going to be a really good implementation. And in those cases where semantic equivalence works, it's great. It's pretty great. But the minute you ask how many orders did I have in the APAC region, semantic similarity is just not going to work.
Yeah.
Because you cannot, there's no way by looking for the meaning of something that I'm going to be able to collect all of my orders in a specific area, right? So you need other ways in order to perform that retrieval. And a lot of companies were running into these challenges around the semantic search being the crux, the main approach. You could put things in a graph database. For sure, you could put your orders in, and you can connect orders and things together, and you can find things that are related as well. But that will give you relationships, right? And so when I talked about earlier about these 3 areas of comprehensiveness, right? So if I use relationships, I can find all my customers or whatever they're similar. I can find all my orders and things. Mm-hmm. The third part of that is if I leverage SQL, and specifically text-to-SQL through an LLM, I can close the gap. And now I can start asking natural language questions, have the LLM generate the queries for me, and I'll get completion for analytic. And I can close all of my gaps just by having different ways whereby I can retrieve that information.
Right, asking for the query instead of the number. And so it seems like graph databases might be preferable for certain reasons, but at the same time, they're also often misunderstood. Is that what you've experienced? And do you know why that is?
Right. So I'm not sure I think much technology today is probably misunderstood and where it actually fits in and applies. So where we see in the research where people leverage graphs, or if for similar for the document, right? So if I have a document, if I embed that whole document, then I'm trying to get then I'm going to get one representation of everything that's in that document. So people started chunking things, right? Mm-hmm. And I can have multiple vectors. But then people started realizing that if I do semantic search on these chunks, that may be specific to just the query, but maybe I need more information that's related to it. Right. And so this is where graphs are now the relationships around things that are associated with those documents helps me expand the breadth of information that I can collect through those relationships. So I can start with meaning, and I can get things that are related to it as well. And this is kind of where you see a lot of this discussion around agentic AI and having different things go after different information, because even we as humans, we make decisions as to how we collect the information that we process.
Yep. No, as you say that, I've literally sat up nights thinking about like, hey, if I'm chunking my data like this, what does that mean? What am I missing? And so I'm also hearing you talk about, leveraging relational data along with these systems, what role, like, how do you see relational data used along with a vector database or used along with a graph database? Like, how important is that? Where do you see it, like, really helping?
Yeah. I mean, yeah, I kind of get. So when we think about where organizations want to go in this AI space, we hear a lot about autonomy, and agentic, and a lot of this automation. And a lot of times that kind of like translates to this idea that we have to get access to our enterprise in real time, and both from a historical nature as well, right? And so if you think about where most of your core information is, they are in systems and databases. And a lot of times that information is structured. So number one, that is the body of knowledge that has to be on the table.
Yeah.
We also see that in structured scenarios, a lot of many organizations are taking that structured data and the unstructured data, and they're structuring it as well, so that you get this this multi-pronged approach when it comes to that, right? And so now when we think about the technology, you enter the data fabric. Now this data fabric and this thought of asking an LLM to generate a query, right? Imagine me trying to ask an LLM to generate a query where information about my customer is in multiple places, right? That becomes very complex. But imagine me having one customer in a fabric, and that is my entree to my question, to my query, and the fabric mitigates the collection of that information. But from the AI's perspective and from the user's perspective, I can ask a question. I can ask any question about the customer and its attributes, and I'm going to get a higher accuracy of the SQL that's going to be generated, because it's very simplistic model, has the metadata and description around it. And the actual mechanics of collecting the information is handled by somebody else, right? And so you can separate out your development for your AI projects, and it becomes clean. It's almost a framework for access to your enterprise, a framework for interacting with your LLM, and there's a framework for the UI. So it's all framework based at this point. And the way that I add more information to make it available to my AI is to add another model and add the relationships to those models, and let the people that understand how to manage where it comes from, how it's secured, they do that. And so this separation of concerns becomes almost, it's very clean and it's very elegant. And it's a very, very good way to scale these types of projects.
Mm-hmm. Awesome. Yeah, no, because I feel like, did you get this sense too? I feel like RAG with vector databases became very popular and people ran off and started doing that. And I didn't even, the first time I heard about leveraging relational data along with your system, I think was like March. And so I feel like this is something that, you hear it and you're like, oh, of course, that's gonna cause an improvement. But a lot of the things that we go through, right? It's like, you just going along forever, and then you hear something, you're like, oh, of course. Do you think companies are still underestimating the importance of like schemas and their data modeling and using these techniques together?
I think that people are shifting, right? And what do I mean by that? So I think that in the analytics space, we have concentrated so much on more traditional approaches that pretty much are wrapped around, the old reporting, right? How we think about reporting and how we actually manage data around that, right? And so now here comes AI, where it can actually generate these queries for you. So that means you don't have to maybe do as much staging and transformation. Things can be more simpler and let the AI just generate these variations of these queries. And so I think a lot of people are rethinking how they're going to approach, the future, and how AI is going to start leveraging our information. And so we're hearing more and more about people. You hear more about like enterprise semantic layers and those types of things. And if you think about, what we just talked about here, how how simple that now makes that interaction with the enterprise. I see a lot of companies shifting, right? So there are many companies that, you know, in their BI days, for instance, had many thousands upon thousands of views that they were leveraging, you know, in across warehouses or lake houses or whatever. But now there's this idea of, how do I now do this historical thing, but also hit my core systems and even external partners directly? So people are starting to think, or, you know, rethink how they actually manage information and make it available.
And so do you think we'll see more of a move to graph, and that's more complete, or what are your thoughts?
Right. So graphs, I think, you know, graphs are kind of like in the middle for me. And the reason why I say that is because in order for something to be into a graph, you still have the activity of putting it in the graph. Right. And so real time becomes maybe not as much real time. Right. And there's also this logic around, how do I translate what I have into this graph structure? Graphs are great for exploring relationships, right? And bringing relationships of information in. But I think that most of the power that we're going to see are going to be accessing our systems directly. And much of that is going to be through SQL type queries. Just think about it, right? So we have been in like 30 years or more, right? In the BI space, everything is pretty much based off of SQL and visualization. The only difference is people were manually doing it. Now, when we think about it, you don't have to manually do it. The AI can generate these queries on the fly. And so that means that a normal user and AI has now in this position where they can get access to information very quickly, provided they have these simplified models available to them to do it. And so for completion, it's going to depend on the question, right? So if I have a question that's relationship based, you know, a graph is probably going to give me quite a, you know, probably more of that information. I may get some from my vectors around the meaning. I may get some relations that come from my graph. And there may be some things in my core systems that round out the information for that question. If I ask a question that has to do with what is happening in my organization from a process standpoint or transactional standpoint, then generating the SQL and pulling that information back is going to be valuable. There may be some relational information around it that will help me explain some of that, as well as some structured information. So it's a multi-pronged approach. And that's why we're, you know, there's all this talk about these agents actually going out and doing that and bringing information together, and then having the LLM analyze that for us.
Well, right, because you can even too look at the graph structure, learn some relationship that you might have not have noticed from a relational database, but you can still write the logic to then include that so that you could use it. Okay, perfect. And then, so are there cases where graph works better with generative AI?
Relational, right? So relationships, right? So
okay.
yes, because it's very and multi degrees. I mean, very degrees of relationships that you can go in. So like I said, it's comprehensive. Like so, and even if you look at many of the RAG approaches, right? And they've evolved tremendously, right? So first we just started with just singular prompts and tried to get information. Now, when we look at these things like deep learning, deep query or I forget the exact term for it, but this idea of now asking the LLM, here's this question, what do I need to do to solve this question? What are the steps that I need to do? What's the data that I need to do, right? So now we're in this place where if we position our organization so that, to your point, we can ask questions, you know, the graph can tell us what information we need from graphs and relationships. It can tell us what information we should look for based off of vectoring and what information we should have from our systems, right? So we've moved into this place where we're now leveraging these reasoning powers of these LLMs to help drive these processes that we would have had to normally go through ourselves. It's kind of exciting, you know, when you think about it. And the idea of having an infrastructure or a framework in place that facilitates that this idea of asking a question, on some of solving an unknown question about an unknown thing for an unknown consumer, right? There's this whole idea of being positioned in that way, because you don't know the kind of questions that people are going to ask. But if you can make the information available so that these types of mechanisms work cleanly, then you can really, really scale really well.
And so what is like the biggest challenge right now when we talk about scaling, and it's like really exciting, and so many things have gotten so much easier, but at the same time, like, managing the data is still like the big difficulty. Do we see that getting any easier? And then, like, what are the big challenges right now that companies are facing when they're actually trying to get to this point where they can scale?
Right. So I mean, I look at scaling in a couple ways, right? A lot of times when people think of scaling, they think of the infrastructure or the technology scaling. My perspective, scale only happens when the processes that support what you implement can scale.
Yeah.
You can have the greatest implementation, product or whatever, and if the processes that support people using it are not sound and in place, or they're very, very cumbersome, it will die. I mean, many things will die. What we see in this adoption of AI is we have a lot of these pilot projects, because a lot of times they're not built on foundations that allow those processes to scale, right? So think about it. I can build a chatbot or whatever, and the first time it's out, that's really great. But what happens is, as more information gets created within the organization, how you're going to handle, how you're securing things, all of these things matter. And that's why how you actually create those frameworks to support it matter. We see a lot of people moving more towards, and you'll see more articles out there on the power of, this enterprise semantic, this concept of enterprise semantic layers. Because if you work with this enterprise semantic layer, then your development works. So for instance, if I'm doing text to SQL and I'm using an implement or representation of a customer, that's not going to change, regardless of where things change data-wise in my organization. It's still going to generate the same SQL. What I now have to do is make sure that as my organization shifts, I connect things up. But those are separated concerns, right? And so other things that I see, and I've seen it, over the course of my 30, 40 years in industry as well, is that when we typically do these types of applications, we have this heavy reliance on the developers to mitigate for all of that. We make them responsible for security. We make them responsible for all of these things that, from a efficiency and focus standpoint, if they could work with frameworks and have the people that understand how data should be governed, how data should be, secured or whatever, those people in those roles, right? And so you can imagine how clean now things work. I'm a developer. I can focus on development. I can work with a framework for this and a framework for that. I don't have to go around asking people, is this, what happens if I don't let this field, do I have to mask this field or whatever? This is not a developer's responsibility and should not be within their purview as well. But a lot of times we push those types of things onto them, which makes the processes even more cumbersome going forward.
No, I mean, I've seen that too. I think that in traditional data projects, right, like the data's set up, you scope something with a stakeholder, and then it's like, okay, you're going to go off and you're going to do some exploratory something for some amount of time. And here it's like, the business needs to be even more involved, because if you're putting documents that are on an internal website or an external website to create a chatbot or something like that, somebody has to understand which documents are going to be used, and they need to contain the right information.
Yes.
And at this point, the developer is actually not that person. And and that I've seen things break down there. And even too, in some of the prompting, it's like, developers understand maybe a little bit better how to work with a computer from a prompt perspective, but at the same time, if the prompts need to get a certain feel, or the example that I always used was I was working on a project where I was building an LLM powered app, and they wanted the communications to be at a 3rd grade reading level. Well, what's a 3rd grade reading level? Because even if you ask an LLM what it is, there's different like ways of defining that. So how does the business want to define that? And what does that look like in terms of number of syllables, number of words in a sentence or whatever? And again, that's the business. And these things start to, there's, just I think a misconception where they think that they're going to be able to give a project to a developer and the developer is going to be able to go off and build it. And I think in these projects, even more so than traditional machine learning, we need to have like true collaboration here. And I don't think that everyone was ready or expecting that coming down the pike. So, So what are some of the biggest flaws you see in process design?
In respect to data management, in respect to
just like building these AI models, getting things like out the door, like where are you seeing breakdowns?
Right. So I can tell you that when we and actually we initiated ours in 2017. Right. It was before generative AI, but we were still generating, stuff or whatever. Right. But the idea there was the initial thought was, and we brought in external researchers from the IBM Watson, actually. And the thought was that that would be the biggest lift. Right. And I think many organizations realized that the actual creating of models and algorithms or models that you need or whatever, that is certainly a big part of it. But the bigger part of it has to be around how these things are going to be embedded into your business processes. So to your point, the business is a huge influencer or partner in that regard. And then there's this idea of how do we get information simply to these people, and how do we keep it so that we can go through our sprints very quickly and get the information that we need available. From the business perspective and from on the implementation side, change management is something that many companies overlook, but change management becomes a really, really big part of it, particularly with these types of projects where you're iterating and moving things in to production fairly quickly. I mean, I'm thinking we were moving stuff in almost at one point monthly, and then at one point it got closer to quarterly. But there's this idea of this constant change and making sure that you have this adoption. So it's almost like a 3-legged stool, right? The business has to be involved. They have to be able to translate what they do, how they work, so that data scientists and AI researchers can interpret it into models, right? And so there were many discussions around, well, what do you do when you develop? What do you think about? What do you use? What's your inspiration, right? And that sounds crazy, but when you're trying to build something that's going to facilitate that AI or data scientists have to have this understanding of what those processes are so they can translate them. One other thing that became a fairly big challenge was the volatility of the enterprise itself, not just the systems themselves, but the processes, right? And so it's much bigger, and I think you kind of alluded to it's much bigger than I think people think. People think it's like, I go in, I just create some models, and I just create some prompts, and I'm done, and that's it. And it's just simply such a bigger machine around it. I don't know if that answers your question.
Yeah, no, totally. Well, and it feels good. It feels like we're vibing here. Awesome. Terry, are you ready to head over to Q&A?
Yeah, let's go.
All right. Awesome. So Bob has asked, do these concepts fall in line with the roles of AI engineer? Would the same data engineering warehouse and data marts used for Power BI also be compatible with LLMs?
I would say technically, yes. But I would also say maybe from a practices standpoint, no, and here's why. When you have applications, there's this idea of stability that's needed or necessary. And a lot of times what we see is when, particularly and when it comes to things like Power BI, those are initiated by end users. They're almost end users, and the volatility of them is not really controlled, right? And so if I were to put out an AI application, I would want to make sure that the underpinnings that I'm using, that those components are controlled and not just willy-nilly changed, right? And so there's this idea of Power BI being this iterative or freer environment for dissemination of information, and then your applications being a little bit more stable. How that affects AI engineer roles, I think that when we move more towards these enterprise semantic models, that there's twofold, right? So for instance, in our implementation, there was this idea of entity and relationships. So objects were built, but then you build objects on those objects, right? And so from a data engineer's perspective, a lot of things that you may have had to pay attention to, like, how do I secure this? How I'm going to name it? Those things, they go away because now you're leveraging components. You're composing based off of other components that have been qualified. And so now you're really focusing on the outcome, right? As opposed to a lot of times we get into these soup to nut implementations where we have to almost start over again with every implementation we have to find the information, we have to secure it. And that type of working becomes less efficient. We find that many customers have said that it's almost unsustainable. And when you try to put AI on it, it becomes even more unsustainable. So the AI engineer role should become more one of where you're generating value earlier and faster and more widely. I don't know if that answers your question or not.
Mm-hmm, mm-hmm. I actually also have a question. So would this not sit with like a data engineer? Like where does the actual separation between those two roles come from?
Data. Well, so so it's not, as far as roles. So for example, right. So for us, we had some data scientists. They had access to the semantic layer, so they were actually they were able to model and compose as well as perform data science activities.
Mm-hmm,
So what that means as far as how you separate your organization, that is, that's on the call of the organization. So you can still engineer on the consumer side, but then there's engineering that's on the producer side, right? Mm-hmm. And so maybe there's that split in that, right? And so there's still this idea of moving things into lake houses or data warehouses or whatever, but the thought around it, the methodology around that can shift and become simpler on the producer side so that you can get more value and reuse on the consumer side. Does that make sense?
No, that makes sense. And yeah, the roles get so squishy anyways that it's always hard. And then we do have one more question. Do LLMs make the manual process of creating ML models less necessary, or are LLM tokens too expensive?
I think it depends on the application. Even during our implementation, we had over 500 models, and some of them were different based off of the need, right? And so I don't necessarily see traditional models going by the wayside. It's certainly a value, proposition, cost benefit analysis, and also whether it suits the outcome. I mean, but truthfully, there are many things that ML models can do. And aside from the token expenses, but they do require, in my opinion, even more policing or whatever around the actual information that's leveraged. The validation becomes a little trickier. So, so in that space, even though you can do many things there, you still have to balance, costs versus value. and if you can do it with a traditional ML model, then I'm thinking that one might win the cost versus value discussion.
Yeah, no, absolutely. Right. Because there are still people out there who are making bespoke models for certain use cases and like doing transformations of variables and fitting things. But then we've also found that with ML, there's a lot of times you can just throw data through a model and it works. And if it works, then it works and we use it.
Right.
And it really depends on your use case. All right. Awesome. Well, Terry, thank you so much for joining. I learned so much. I had a fantastic time chatting with you. I hope you had fun as well. All right. Well, everyone, thank you so much for joining. I hope to see you again next week. And again, thank you, Terry.
Thank you.
Bye.